So earlier in this chapter, we were trying to use integral to find the area under the curve. So remember this example that we had at the beginning. We said that we are trying to find the area under this curve here. How do we do that? That's what we'll see in this section. So let's say that we want to find the surface area under the curve minus x squared plus 5. One way to do that is that to cover that area using a shape that we already know the area of, and one of those shapes is rectangles. So what we do in this case is that we try to overestimate and underestimate the area under the curve by taking many small rectangles that cover both. In the first part, they cover less area than the actual area, and in the second part they cover more area than the actual area. So then how to find that that actual area that we are trying to do? So first we need to compute the area that is covered by those rectangles here. How to do that is that we know that the area of a rectangle is just the width times the height in this case. So we'll just compute the width times the height for each small rectangle here, and then multiply and then add them, sum them up in order to find this area that is covered by the rectangles. Then in the second part, we'll do the same. We'll try to multiply the width by the height, and then we sum them up. Then we'll try to find then the actual area will just be between this area here and this area here. So we'll end up with, let's call this A1, and then this is A2. Then A, which is the area that we are trying to find, will be between A1 and A2. This is the approximation we are trying to find. So just to start with, let's try and find how to write that area, this area here that we are looking for, this area. In order to do that, we'll first need to know how many rectangles there are and what is the width of each rectangle. Let's say that we don't have these numbers here, and we only have the curve minus x squared plus 5. How can we find the area under that curve? So we take the left endpoint, the point here where the curve ends, and then the point where the curve begins, and then we do 10 over 5 minus 0 over the number of rectangles that we want. In this case we have 5 rectangles, so we can do this, and then we'll end up with 2 over 5. The formula to find the width of each rectangle is just b minus a over n, where b is the left endpoint, a the right endpoint, and n is the number of rectangles, the number of rectangles. Okay, so now we found that the width of each rectangle will be 2 over 5. This will be constant. Now we need to know what is the height of each rectangle. If you look at these rectangles here, they all share one common thing, is that their left endpoint ends at the left endpoint here, which is 2 over 5, 4 over 5, crosses or meets the curve at this point here, and this is where the rectangle ends. So the height that we'll be using will come from the left endpoint. And what would be the height in this case? It will be just f of 2 over 5, or f of 4 over 5, or f 6 over 5, and so on. As for the width, as we said, it will just be 2 over 5 because it's the constant. It's only the height that is changing. So now that we found what is the width and what is the height, we can go on and try to find the area of one of those rectangles. So let's start with this rectangle here. So the area of this rectangle will just be 2 over 5 times f of 2 over 5. The area of the second rectangle will be 2 over 5 again, because they have the same width, times f of 4 over 5. Then we can add the third rectangle, which is also 2 over 5 times f of 6 over 5, and then we can keep going. So once you write everything, you'll find that to write that sum, it will be easy to see that we can factorize by 2 over 5, and then we'll just end up with f of 2 over 5 plus f of 4 over 5 plus f of 6 over 5, and so on. And if you look again at 2 over 5, 4 over 5, 6 over 5, it's just like writing 2 over 5, f of 2 over 5. They are just multiples of the other. 4 over 5 is just f of 2 times 2 over 5. F of 6 over 5 is just 3 times 2 over 5. And all the other images will also have the same because as we said, the length is constant. So we just keep multiplying by let's say r is the rectangle from 0, if I can say that. So we can again come and rewrite this whole thing as just of 2 over 5 f of I 2 over 5 I times 2 over 5, and then the sum will go from 1 because we have 2 over 5, so we'll go to 1 up to, let's say we have 6 over 5, 8 over 5, and then 10 over 5. So we'll multiply this up to 5. So this will be the area covered by the rectangles of our first approximation. Now let's move on to the second approximation and try to find the area as well. So now for the second part, we'll try to once again find the area that is covered by these rectangles here. So what we need to do is again to find the width and the height of these rectangles. How to do that is again, if you look at this example and this example, the rectangles seem to have the same width because they are both the left endpoint and the right endpoint, they are the same. We have 10 over 5 here, 10 over 5 here, and then 0 here, 0 here. So the width will just be 2 over 5. Now for the height, in this case, the height is governed by the left endpoint. So if we look here, the height of this rectangle here is determined by when the left part of the rectangle crosses the curve minus x squared plus 5. So in this case, we'll end up with f of 0 plus 2 over 5 f of 2 over 5 plus 2 over 5 f of 4 over 5 plus 2 over 5 f of 6 over 5 plus 2 over 5 f of 8 over 5. Now, if we want to compare this with the first part that we had, in the first part we found that we had 2 over 5 times f of 2 over 5 plus 2 over 5 times f of 4 over 5 all the way until 2 over 5 times f of 10 over 5. This is here plus here. So if we look at it, the difference between the first and the second is here in these points, the images. Then we can just, if we look at it again, it's just a difference of 2.2 over 5. So if we do 0, it's just 2 over 5 minus 2 over 5. 2 over 5 here, 2 over 5 here is just 4 over 5 minus 2 over 5. So we can just rewrite this second part here as, we can rewrite it as just 2 over 5 times, we can just factorize with 5 as f of 2 over 5 minus 2 over 5 plus f of 4 over 5, 2 over 5, 4 over 5 minus 2 over 5, and so on. So this will keep going until we reach f of h of 10 over 5 minus 2 over 5. And this is the same as writing this as sum from I equal to 1 to 5 of 2 over 5 f of 2 over 5 I minus 2 over 5, or just writing it as the sum I1 to 5 2 over 5 f 2 over 5 I minus 1 I minus 1. This is one way of writing this, the area of the second part. So once we find these two areas, we just go and try to estimate the area that we want, since it will be just A will be between the sum from I equal to 1 up to 5, 2 over 5 f of 2 over 5 I, and then here we'll have sum from I equal to 1 up to 5 f of 2 over 5 times I minus 1. Then we'll just have to solve this sum, and then estimate what A is.